Hi folks, I'm Sai Srirampur. I head up the customer success team for all the Postgres managed services on Azure. My team works closely with customers on data modeling, performance tuning, and migration aspects to ensure a smooth onboarding experience. I'm here to talk about Azure Cosmos DB for PostgreSQL from the customer eyes. So let's get started. A customer journey to adopt a database consists of answering five main questions. First is customer needs to know what is the database in first place. Second, they need to know whether the database can help solve their use case. Third, if there is a use case fit, they go through a proof of concept to make sure that the database solves their real world problem. And fourth, if the POC is a success, they take up the effort to migrate to the service. And last but not the least, post-migration, they learn the best practices to run the database in production. This talk provides a bird's eye view of the customer journey by probing into each of these questions in the context of Azure Cosmos DB for PostgreSQL. Goal is to provide direction and guidance to any customer looking to test Cosmos DB for Postgres. And just for context, as I just have 15 minutes, I don't plan to do a deep dive into each of these questions. I'll just give important pointers, and I have a ton of pointers and links for future reference. So first, what is Azure Cosmos DB for PostgreSQL? It is Azure's fully managed distributed SQL offering built upon the core benefits of PostgreSQL. It stays native to Postgres, supporting the latest version and features such as the JSON-B data type, rich indexing features, various extensions like PostGIS, and so on. It is powered by the fully open source Citus extension to Postgres for distributed scale. To achieve distributed scale, Azure Cosmos DB for Postgres extends Postgres with the superpower of distributed tables. You can start small by building your apps on a single node, the same way you would with PostgreSQL. As your app scale and performance requirements grow, you can seamlessly scale to multiple nodes by transparently distributing tables. Now that we know what the product is, let's go to the second step and do a deep dive into use cases where Cosmos DB for Postgres can bring value. There are many real-world applications across different verticals solving business-critical problems, and all of these can be synthesized and characterized into two higher-level buckets. First are multi-tenant SaaS apps, and second are time series IoT applications. Let's talk about multi-tenant SaaS apps. If you're running a multi-tenant SaaS app that is growing very fast, that is you're onboarding new tenants on a day-to-day basis, and your application is outgrowing your single node database, Cosmos DB for PostgreSQL can bring a lot of value. Second, it can also help drastically simplify life of workloads that already have a homegrown sharding solution, which is complex. It is incurring large tech debt and very inflexible to scale out and rebalance tenants. Cosmos DB for Postgres has many specialized features to build scalable enterprise-grade SaaS apps. A few of them include automatic sharding of tenants across multiple nodes, online scale-out to add more nodes and rebalance tenants seamlessly. This is the horizontal scale-out feature, right? Third, tenant isolation to isolate large tenants or hotspots to their dedicated nodes and give them dedicated resources. This is for tenants which are very large, like the VVIP tenants, and you want to give dedicated resources for them. Fourth, comprehensive tenant monitoring features based on the size of the tenant, the traffic that each tenant generates, and so on. Row level security per tenant to avoid cross tenant access, and so on. Let us look at a real world customer use case who is running a mission critical application, a SaaS application on the service. Algolia uses Cosmos DB for PostgreSQL to power their multi-tenant SaaS application. This app provides analytics on search data, enabling real-time business decision making for their customers. Right? The app is used by 11,000 plus tenants, 11,000 plus customers. And there are over 10 billion rows stored in two clusters across two different regions, the Europe and the US, and adding up to over 20 nodes, right? And Cosmos DB for PostgreSQL ensures that 95 percentile of their queries finish within 800 milliseconds at a constant rate of 100 requests per second happening throughout the day. Let's talk about the second use case, the second bucket, which is time series and IoT apps, right? And these applications provide real-time insights on telemetry data. And this telemetry data could be from devices, vehicles, logs, events, and so on. And these applications have a implicit requirement of scale, right? Because the data is actually generated from machines, right? And you want to ensure that, as you onboard new devices and like the data is getting generated, the application, the database scales with the application, and hence they require a database that can scale to multiple nodes, right? If you're building such applications and want to do it in the rich and open Postgres ecosystem, Cosmos DB for PostgreSQL can make that happen. And there are features like, horizontal scale out, which we already talked about, JSON B to store and index semi-structured data, native time series APIs for, partitioning, expiry based on time, and archival using columnar storage provide a ton of value to build, these scalable time series IoT applications. Let's do a overview of a customer who runs an IoT application. A real world customer reference in this is HSL, and this organization is responsible for more than half of all the public transportation in Finland. And they capture time series data from their network of 2,000 buses in real time and provide rich dashboards for vehicle monitoring. The dataset size is over a billion rows, and they did the migration around a year ago, and queries that used to be, over 10 minutes now finish instantaneously because of, the scale out capabilities, the parallelism capabilities of the service. And due to the managed service, right, as the service is all on Azure, it takes care of high availability, it's a managed service, right? Like all those bells and whistles, which I'll go through in the next future slides. They were able to save ops cost by 2x. So at this stage, you have decided that there is a potential use case fit in your journey, right? Like your application is either a multi-tenant SaaS app or a time series IoT one looking to scale out using a distributed Postgres ecosystem. Now you want to put the database to test, right? Where you want to test a real world use case using Cosmos DB for PostgreSQL. Following are the 3 higher level steps to execute a successful proof of concept, right? And I won't go into detail for each of these steps. We'll cover a few important pointers. However, I have clear checklists with links for future reference. The first is to spin up the database with the right sizing, right? And Cosmos DB for Postgres gives you 2 deployment options. One is the single node option, and second is the multi-node option. Smaller apps that don't have the scale yet can start with single node and always scale in the future. You can add more nodes and seamlessly scale out. And a single node can scale up to 64 vCores and 2 terabytes of storage. For larger apps, you can start directly with a multi-node environment, and multi-node can scale to hundreds of nodes. In regards to the right sizing of the deployment, this varies customer to customer, but a common thumb rule is to provision a cluster whose total compute and storage across all the nodes that they have provisioned matches the compute and storage that you're using on the source database, right? And the advantage that the managed service gives you is you start with this configuration and you can always scale up and scale down based on how the performance testing looks, right? So once the cluster is spun up, the second step is, where you model the data and ingest it, right? Like for the later stages of testing, right? And most important step of data modeling is choosing the right distribution column, right? And Cosmos DB for PostgreSQL distributes data across nodes based on the hash of a column, right? And this column is called the distribution column or the shard key, right? And shard key dictates, what performance and scalability you can get with the service. I won't get into this piece in detail, but I have a link to my talk where I talk about how to choose the right distribution column, right? But at a high level, right, across various customers, we have seen that a column that adds natural dimension to data is a good shard key, right? And this column represents the central piece of the application. It lives at the heart of the workload. A few examples here are, say, in multi-tenant SaaS applications, right? A tenant ID, which could be the organization ID or the company ID or the customer ID, is a good candidate, to distribute your data and tables. In IoT applications, the device ID is a good candidate because finally, all the analysis, all the insights are generated on data that is generated from, devices, right? So device is the central piece of the application, and device ID is a good distribution column in such scenarios. So once the distribution column is ironed out, you can follow a few other data modeling tips. I have a link here if you see to iron out the data model. And post data modeling, you have your tables created, right, and distributed. And to load data into these tables, you can use many approaches, right? Like there is the PG Azure storage extension, which lets you query and load data directly from blob storage. You can use the native Azure integrations like Azure Data Factory, Databricks, Azure Stream Analytics to load data, or you can use the native Postgres commands like the copy command, inserts, updates, deletes, which are like simple CRUDs, right? Or PG dump and PG restore to load data, right? So once the data is loaded, we have seen customers test the database on various dimensions, right? It could be on the performance front, scalability front, security front, and also DR and resiliency front, right? So for performance testing, you can use tools like PG Bench and JMeter. I also have a link here for performance tuning guidelines that you can follow. For scalability testing, you can use the shard rebalancer utility that we provide for online scale out. For security testing, we have like a bunch of features like private link, roles, row level security. And for DR testing, we have like point in time recovery features, cross region read replicas, right? So at I won't get into the POC process, but like this slide captures a comprehensive checklist of what needs to be done to execute a successful POC against Cosmos DB for PostgreSQL. So the third step is done where you evaluated the database against your real world use case. Everything is looking good, right? And now you want to, actually migrate to the service, right? And most learnings that you did in the POC phase for data modeling and performance can extend to the actual migration, right? And a few important pointers on the migration side are for deployment management, right? Like you have burstable compute on single node, which is very cost efficient for your dev and test like workloads, right? And there are also open source Docker images that we provide. You can use for your like dev and test environments. For production clusters, like typically you deploy it on the managed service, right? Like, and where you can configure high availability, you can all use all the bells and whistles of the managed service, right? And on the migration side, as I said, like the best practices from the data modeling and querying in the POC will extend here as well. And I'm sharing like a detailed migration guide for future reference. So at this stage, you have evaluated the database, you've done the migration, right? And now you're running the database in production. So you want to make sure that you get the most out of Cosmos DB for PostgreSQL, right? So I'll show all the features that it provides to manage your database through a demo. So let me go ahead and get started. So to help with the demo, I provisioned a cluster right before. And if you see, this cluster is a single node deployment with 2 vCores and 8 gigs of memory. So it's pretty small, right? And I have like I have Postgres version 15, which is the latest version. I have Citus version, which is 11.2, which is latest. And this shows you that single node, right? Like, and it is available. I don't have high availability configured for now, right? And once you're in production, you have a ton of features to manage the database. The first one I want to highlight is the scale tab, right? Where you can either scale up the single node up to 64 vCores and 2 terabytes of storage, or you can transform from this single node to multiple nodes, right? So you just like add change it to 2 nodes or 3 nodes, and you can go up to 20 nodes. This is just a UI limitation, right? Like we can get you to hundreds of nodes as well, right? And then this is one tab, which is the scale tab. You can scale up, scale down, and scale out, right? Very seamlessly. Next, you have the networking tab, right? Which lets you, set up firewall rules. You can also create like private links, right? And then there is the connection string tab, right? And the service comes with inbuilt PG bouncer. So PG bouncer helps with connection pooling, right? So you just click on PG bouncer and, the connection string slightly changes to, 6432. You can use that in your applications. And PG Bouncer enables 2000 connections to the database. And if the deployment is pretty large, we can consider changing that as well, right? And then there are a bunch of parameters that you can change. These are all, Postgres and Citus specific parameters, right? And then for cluster management, you have roles. So you can create roles. I just have the Citus user, but you can create more roles as needed, right? And then you have the global replication feature, right, where you can create read replica. So currently, this cluster is provisioned in East US, but I can add a replica in, a different region, right? I do try replica, and I can do it in, like, say, West US, or, like, a bunch of other regions, right? This is for DR purposes, or, if you want to create replicas for offloading your analytics, right? Like, so that your primary doesn't get affected. For those reasons, you can use this feature, right? And then there is the Insights tab, right, which will let you monitor the database in real time, right? So there are a bunch of, like, useful metrics here, IO, network, connections, right? And then you can also create alerts, right, based on these metrics, right? So you can select the signal. The signal can be, any of these, right? Like, it can be the active connection, CPU, and stuff like that, right? And there is logs also, where you can, automatically see logs in log analytics, or push them to, blob storage, or push them to event hubs, right? So I'll run a query to show you that logs. I configured log analytics, if you see, right? And there are other features like, in-place upgrades, which is pretty cool. So in place, you just click a couple of buttons and you can upgrade to the latest PostgreSQL version and Citus versions. This is blurred out because, like, I'm already in the latest versions, right? There's also a start-stop feature where you can stop the database, right? And this is for saving costs. So for you, this is suitable for your dev and test clusters, right? Like, to save costs, you can stop it as well. You have the restore feature, which is for DR purposes, right? Where you can restore until a minute. So, like, until a minute old, you can spin up a new cluster, and which is a fork of the existing cluster, right? So this is for DR purposes, and even, like, testing purposes, right? Say you want to do an upgrade, you test it on your fork, right? First, make sure that everything is fine, and then you move to production, right? So yeah, and there is the restart feature, right? You can also reset the password, right? So there are a ton of, like, managed service features which make your life very easy to manage the database, right? And helps you not worry about the database, right? Rather, you can focus on building applications. So yeah, so to summarize, you can go through this deck as a reference for your journey to get onboarded to Cosmos DB for PostgreSQL. And I gave, like, 5 steps, starting from, what is the service, why use the service, right? Then getting into how to go through the testing and how to do the migration and how to get the most of this service, right? And happy testing, and thank you.